Every organization making products would like to deliver their products defect-free, and they would like to achieve this at minimum cost. Unfortunately, many companies spend up to 24% of their production budget on the 5 quality expenses: scrap, rework, repair, warranty, and quality control. In many cases, the true cost of poor quality is hidden, with the result that quality problems are never fixed. By comparison, world-class leaders in quality control have sustained defect rates less than 1/100th the level of companies with traditional quality control, while spending less than 3% of their production on these 5 quality expenses. Hello, I'm Martin Hinckley, President of Assured Quality Incorporated and author of Make No Mistake. Working with Gwendolyn Galsworth, we developed the course on achieving perfect quality through Poka-Yoke, or mistake proofing, so that everyone can learn how to achieve the highest levels of quality with the least investment and effort. Mistake proofing is complementary to and an extension of work that makes sense. Not only is the information essential for the task embedded in the work, with mistake proofing, the correct methods, actions, and sequence of every task are also embedded in the work. Variation was the first major source of product defects identified, and the earliest statistical methods for controlling variation were developed just a little more than a century ago. Since that time, tools and control methods have evolved to the point that variation rarely causes any defects. To illustrate, the aerospace division of GE reviewed every problem that customers encountered in a 10-year period that required their support. With only one exception, every problem requiring action by GE was traced to a mistake rather than excessive variation. To understand why this is the case, consider a simple bolt. The variation in the material strength, fastener diameter and length, thread pitch, torque, and friction can all be described statistically to characterize the distribution of load-carrying capacity of the bolt. However, if the fastener is inadvertently omitted, the load-carrying capacity at the location where the bolt should be installed is 0. Mistakes such as this are probabilistic events rather than statistical distributions. It is impossible to predict the magnitude of the consequences of mistakes from distributions. It is impossible to predict the frequency of mistakes with sampling inspection, particularly when most outliers, which are the outcome of mistakes, are discarded. Hence, the statistical approach of measuring mistakes fails. It is also impossible to predict when mistakes will occur. Consequently, statistics do not provide any useful tools for controlling mistakes. Unfortunately, many mistakes can occur during a bolt installation, including using a bolt with the wrong diameter, wrong length, cross-threading the bolt, or forgetting to tighten an installed bolt. To illustrate, during the F-117 production, 4 out of 5 bolts that held one wing in place were left out. In flight, the aircraft began vibrating so severely the pilot ejected. The aircraft crashed, and the loss of the aircraft and the investigation cost roughly $100 million. Most defects, like this case, are caused by mistakes and are not variation. Our course in mistake proofing contains 7 modules. The first is why most quality control fails, as we have already briefly introduced. Statistical methods outwardly seem simple because a single approach seems to address every problem. But the difficulty is it simply doesn't address the problems associated with mistakes. The second module addresses the exceptional challenge of mistakes. Mistake proofing requires unique solutions to address every kind of mistake. And companies that are effective in controlling mistakes have an average of 12 mistake-proofing devices for each minute of value-added work. This illustrates how extensive mistake-proofing has to be to actually achieve control over mistakes. We then introduce the SMS method to world-class quality. Because the Six Sigma DMAIC method is ineffective in characterizing and controlling mistakes, a new quality control method is required. The best quality control methods are each effective because they target mistakes. We can simplify to eliminate half the mistakes with enormous savings. We can mistake-proof to control virtually every mistake, which pays for the investment. and we can convert adjustments to settings, eliminating 98% of the setup and adjustment mistakes while saving money. This is the SMS method. Our next module is on preventing mistakes through simplicity. Mistakes and defects are highly correlated with task complexity. So one of the very best methods for improving quality that can save enormous time and money is to simplify every product, task, and activity. Here's 3 examples of products that have been changed or simplified that eliminate many mistakes: a cable clamp and some aerospace products. Notice that in the second example, the cost is 1/25 the original cost. And in the bottom example, we've gone from over 11 parts to 5 parts. Our next module is on the secrets of mistake proofing or traditional poka-yoke. Controlling each mistake using poka-yoke often requires unique solutions for each problem. Novices to mistake proofing in many cases have difficulty finding such solutions. To find great mistake proofing solution, we first classified the problem. Here's a square part that could be placed in 6 different positions around this bolt hole pattern. It could also be placed in 4 different orientations. So those are the classifications of the problem. Once we've classified it, we use those classifications to look for solution principles. Interference or asymmetry prevents assembly in the wrong location. And here's an example of a solution that applied those concepts. Perfect settings every time. As Toyota discovered, setup errors are the major contributors to excessive variation. They discovered a technique for eliminating setup errors. Traditional control of variation is based on adjustments. A key concept is we eliminate adjustments by converting them to settings. That produces less variation than Six Sigma. It eliminates all of the data collection. It puts the control of variation upstream of the process. It eliminates opportunities for many mistakes, and we can cut the setup and changeover times by 97 to 99%. This discovery helped them eliminate statistical methods from the factory floor, demonstrating how Toyota pioneered world-class quality without ever following or applying the Six Sigma approach. Finally, our last module focuses on deploying great solutions every time. A key to getting outstanding solutions deployed is recognizing that there's at least 5 ways to solve every problem. And it is the comparison of solving the problems 5 ways that always leads to great solutions. Here, for example, are 8 different concepts of a key function. It is the comparison of the solution for our particular problem that leads to great solutions deployed every time. We have helped many companies deploy effective mistake-proofing solutions and have shown that outstanding quality is not just free. Properly deployed, mistake-proofing can result in significant cost savings. We invite you and your companies to learn how to achieve exceptional quality while saving time and money in development and production through our training course. Thank you.